Good afternoon, viewers. I greet you once again. My name still remains the same as Nicholas. So I am here today to teach a topic called calculus. So I'm starting with the introduction of calculus. Now, as we all know in mathematics, now calculus is divided into two parts. We have what is called differentiation and we have what is called integration. So what I'm going to do here right now is I am going to take it part by part because I can't take all at the same time. I am going to start with the first part of calculus, which is called differentiation. Then in the next part that will be later, I am going to start with integration. But for now, let me start with part one of it, which is called differentiation. Now in mathematics, when we are dealing with differentiation, we'll be hearing things like differentiate, we'll be hearing things like derivative of a function. Now in mathematics as a whole, especially when it has to do with calculus, now differentiation as a whole is divided into three major rules. It's divided into three major rules. These three major rules has to do with what is called the product rule. That is the first rule of differentiation. And we also have the second one to be quotient rule, and the third one to be composite rule. The composite rule can otherwise be called the chain rule. Now, starting with the rules of differentiation. Now, like I said before, our calculus is divided into two parts. We have what is called differentiation. That is the first part of calculus, differentiation. Then the second stage of it is what we call integration. Integration, yes. But right here now, I am starting with the first one, which is called differentiation. So I'm going to bring it out as a subtopic, differentiation. So when taking the differentiation, like I said before, we have three rules of differentiation. So the first one, rules of differentiation. Rules of differentiation. The first rule of differentiation we have is what we call the product rule. Product rule. So when taking the product rule, we have the product of two variables multiplying each other in this form. So we have y equal to uv. Then the second rule, we have what is called, that is the quotient rule. So for the quotient rule, we have the two variables dividing each other, which is y equal to uv, y equal to u over v. And for the third one, we have what is called the composite rule. Like I said before, it is also otherwise called the chain rule. So these are the three rules of differentiation that we are having. We have what is called the product rule, we have what is called the quotient rule, and we have what is called the composite rule. So I will be taking on the first one, which is called the product rule. Product rule. Now in product rule, Like I said from the beginning of it, we have y equal to uv. Now a good example is going to be taken on this. For example, the students are asked to differentiate. Example, differentiate y equal to 3x plus 5, then x minus 4, w dot r dot t dot x. Now the student will ask, what is the full meaning of w dot r dot t dot x? Now this means with respect, that is with respect to x. So that is the meaning of that. Now looking at the question on the board, how do I differentiate that? For me, differentiating this is very simple. Like we all know, we are having two parameters here. We are having the first parameter multiplying the second parameter. That makes it to be a product. Now when the two parameters are dividing each other, we don't call it a product anymore. We call it quotient. Now we don't use the formula for product for quotient, and we don't use the formula for quotient for product. Now for me to differentiate this, I have y equal to 3x plus 5. Then I have x minus 4. What do I do? If we can recall, I have y equal to uv, y equal to uv, representing the two products I am having, y equal to uv. Then what do I do? Now for me to start differentiating this, I already know that my u is representing my 3x plus 5, then my v is representing x minus 4. Now all I have to do here is to differentiate my u with respect to x. Then if I'm differentiating u with respect to x here, I am going to have the u over the x. The u over the x. That means the derivative of 3x, we give 3, and the derivative of any number, we give 0. So if the derivative of 3x is equal to 3, that means the derivative of v with respect to x, we give 1. So that means if we have something like y equal to 2x and we are asked to differentiate y with respect to x, that means the y dx there is going to give us 2. If we have something like y equal to 5x raised to the power of 3 and we are asked to differentiate y with respect to x, all we have to do is to bring down the power, multiply the power by the number that is serving as a base. That will give us 5 multiplied by 3, which is 15. Then we reduce the 3 by 1, which is 2. That means the derivative of 5s cubed, we give 15s squared. So we are still following the same principle on this. Derivative of 3x, we give 3. Derivative of x, we give 1. Like I said before, derivative of any number, we give 0. Derivative of any number is 0. Now, for me to solve for this product rule, I have to apply a particular formula, which is this. That means from here, I am going to have the y, the x, that is the y over the x, because we are differentiating y with respect to x. That is meant to be the y over the x, then equal to u, the v, the x, then plus v, the u, the x. What do I do next? Very simple. Now, for our u is 3x plus 5. Our v is x minus 4. That means we have to substitute the value of u, which is 3x plus 5, into the formula. The value of v, which is x minus 4, into the formula. The value of the v dx, which is 1, into the formula. And the value of the u dx, which is 3, into the formula. Now by so doing, that means we are going to have the y over the x equal to our u. That means our u is 3x plus 5. That will be 3x plus 5. 3x plus 5 multiplied by the value of the v dx, which is giving us 1, multiplied by 1. Then we have plus, that is coming from the formula, plus v. The value of v is x minus 4. We are substituting here x minus 4 multiplied by the value of the u dx, which is now 3. What do we do next? We expand the bracket. When 1 multiply anything, we are surely going to have that same result back. When you use 1 to multiply anything, you are going to have that result back. 1 multiplied by 3x plus 5 will surely give us 3x plus 5 back. Then plus x. We are expanding, we are removing the bracket. Plus x multiplied by 3 will give us plus 3x. Then right here we have plus times minus, that is minus. Then 4 multiplied by 3 is 12. So that means this will give us minus 12. So what we need to do next here is just to collect like terms. That means 3x and 3x here are like terms. 5 and minus 12 are like terms. That means from here, our dy, the x, we give 3x plus 3x, that is 6x. Then we have plus 5 minus 12, that will give minus 7. So this is the derivative of the question we have on the board. The y dx is equal to 6x minus 7. Now, aside us making use of this formula to solve, there is also a short method we can use to solve that. That means probably in my next lecture I am going to show that. All we have to do in that process is just to expand, remove the bracket from the question they have given to us, expand. When you are done removing the bracket and expand by multiplying what you have here by this and this by this, then you differentiate next. By the time you do that, at the end of everything, you will surely end up having the same result. So I hope this is clear. So in our next video, we are going to look at the shortcuts to this. Please, all I have here is for the serious-minded viewers. Please just go to my YouTube channel, click on the notification button, subscribe and like. Thank you very much, and watch out for my next uploading. God bless you.